Hello, happy people. Today's first lesson for pre-calculus is on function notation. So I'm just going to go through the PowerPoint like I would have done while I was at school. So we're going to be talking about function notation. So the first thing we need to know about is what a function is. If you ever feel the need, go ahead and pause this video so you can write down any notes you want to take, including definitions like this. So a function is just a relationship in which there is one element in the range for each element in the domain. In fact, there's one and only one. And so if you had me for Algebra 1, hopefully you remember the fox story where Mr. Fox found one and only one animal in the domain that Mrs. Fox had one and only one recipe for that she would cook on her range. So the domain is anything you input for our most of our functions. We're going to use x, and a range is a set of all outputs or y's or f of x's or g's of x's, whatever you say. So domain is what's going in, range is what's going out. So remember, a function's like a machine. You put something in, you get something out. You put in something from the domain, you get out something from the range. And there can be one and only one, which means we don't share items in the domain. Or again, in Algebra 1, I taught you that if functions are like friends, you don't share x's. So we're not going to share x values or items in the domain. So there are two ways to tell if we have a function. If we're given a table or a set of points, you can't, like I was saying, you can't share an element in the domain or you can't share an x. So if we look at the set function of -3, 0, 4, -2, and 2, -6, there is no shared item in the domain or in the x's, so it's a function. But if we look at the points 4, -2, 4, 2, 9, -3, and -9, 3, you see the first 2 points share x coordinates, so they share parts in the domain, so that is not a function. If we have a graph, we're going to use a vertical line test. So if you can draw a vertical line on a graph and it passes through no more than 1 point, then it's a function. So for example, if we look at the points on our first graph, you can put a vertical line through each of them and it only touches each of those points. So it is a function, and that again comes back to them not being able to share x values, so they shouldn't share x coordinates. On our second one, our sideways parabola, if you look at our red vertical line, it goes through 2 points. In fact, any vertical line you put through there would go through 2 points, except for one at the end. So that is not a function because you cannot pass through more than 1 point. So for example, we're going to determine whether these two functions based on the graphs are these two relations based on the graphs, are they functions? So the first one, if I put any vertical lines through there, trying to make them as vertical as possible, if you notice, whatever vertical line I put through touches a whole lot of points because the shaded area, remember, means it's an inequality. And since an inequality, all of these points are part of the solution. And so these lines are touching lots and lots of points. And since it's not just touching one in each part, this inequality is not considered a function. Function. All right. On the other hand, if we look at our, I believe this is a cosine function. If we look at our cosine function, if we put any vertical lines through, they only touch each part of our function once. There's no place where you could put a vertical line and it would touch it twice. So our cosine function is a function. So the vertical line test, if it touches more than 1 point, not a function. Doesn't touch more than 1 point, is a function. All right, moving to function notation. F of x is read f of x. Remember, it's not that's not f times x. That's f of x, meaning whatever x we plug in is going to give us the f of x that we get, the function we get out. So to evaluate a function f of x for a given value at x, we're going to be given a value inside the parentheses. So we're going to find f of negative 4. F of x equals 3x cubed minus 7x squared minus 2x. So what that means we're going to do is we are going to plug in whatever values in the parentheses for x, and we're just going to simplify. So I have some room for this. So if we have f of x, f of negative 4, if f of x equals 3x cubed minus 7x squared minus 2x, to find f of negative 4, we're going to plug in negative 4 whenever we see an x. So we're going to get 3 times negative 4 cubed minus 7 times negative 4 squared minus 2 times negative 4. So if we go ahead and we put that in a calculator, what we're going to get is we are going to get negative 296. So f of negative 4 is negative 296. So this statement actually tells us a lot. It tells us that if I plug in negative 4 into the domain, in the range, I will get out negative 296, and it tells us the point negative 4, negative 296 is on the graph of our function. All right, so all I have left for you are some examples. So we're going to do these 3 examples in detail, and then that would have been the lesson for the day. So the first example is f of negative 1 when f of x equals negative x cubed minus 1. So to find f of negative 1, we are going to plug in negative 1 whenever we see an x. Now, when this is the opposite of x cubed, we're going to keep that negative or that opposite out front. Replace the x with a negative 1 cubed minus 1. So negative 1 cubed is negative 1. So we're going to get the opposite of negative 1 minus 1. Opposite of negative 1 is 1. And 1 minus 1 is 0. So f of negative 1 is 0. So again, this tells us a couple things. If I plug in negative 1 into this function, I will get 0. For negative 1 in the domain, I'll get 0 in the range, and the point negative 1, 0 is in our... All right, our next example is g of 3, when g of x equals the absolute value of 3x squared. Remember, the absolute value means the distance from 0. So remember, it means that whenever we plug anything in to those bars, we are going to get a positive number. So we're going to plug in our 3 here for x, and then we are going to simplify. So remember, these bars mean to find the distance from 0, so that's always going to be a positive number. So if I plug in 3, I will get the absolute value of 3 times 9. And so I'll get the absolute value of 27. How far is 27 from 0? Well, it is 27 units from 0. So our answer for g of 3 is 27. So again, if I plug in 3 from my domain, I get 27 in my range. I know the point 327 is on the function of this graph, which we learned in Algebra 2 and geometry that it is a V shape because absolute value takes all those negative values and folds them back up to be positive, because remember, distances cannot be negative. All right, got one last example for you, and now we're going to find j of c minus 5 when j of x equals x squared minus 7x plus 4. So to find j of c minus 5. Now, so far we've only plugged in integers. This time we're going to plug in an expression, but it's the same idea. We're going to, every time we see an x, we're going to replace it with a c minus 5. So I'll have c minus 5 squared minus 7 times c minus 5, and then I'll have plus 4. All right. So I just took every x and replaced it with c minus 5, and now we have to simplify. Now our answer is not going to be a number. It's going to be an expression because there's no way for us to get rid of those c's. So remember to take c minus 5 squared. I'm going to have to box or FOIL, which remember is just the distributive, fancy way to use the distributive property. So c times c is c squared. Now I get negative 5c and negative 5c, so I'll get minus 10c. And negative 5 times negative 5 is positive 25. And if I distribute my negative 7 through, I'll get minus 7c. Negative 7 times negative 5 is a positive 35. And then I still have plus 4 at the end. That's plus 25. All right. So if I just combine my like terms, I have a c squared with nothing else. So I'm going to keep that c squared. I have a negative 10c and a negative 7c. So that's a negative 17c. And I have a positive 25, positive 35, and a positive 4. And that adds up to 64. So plus 64. So j of c minus 5 is c squared minus 17c plus 64. So that one, items in the domain can be expressions. So we know if we plugged in c minus 5 into this function, out we get another expression with c, which is c squared minus 17c plus 64. So we're still using the function as a machine to plug in something from the domain to get something out of the range. And your homework then is a worksheet. I hope you all have a great day.